Welcome, everybody, to the High Pressure Podcast, the weekly air quality discussion. My name is Jeff Beamish. I'm an air quality meteorologist at Sonoma Technology, based in the San Francisco Bay Area.
And I'm Patrick Zahn, the lead air quality forecaster at Sonoma Technology.
And I'm Steve Irwin, also an air quality forecaster with Sonoma Technology.
And we are talking smoke here in Northern California. A lot of it has been lingering due to several large wildfires burning across the state. We're going to take a look back at the smoke that occurred across Northern California this past weekend. And we're also going to take a look at the forecast because more smoke may be heading into Northern California. But first, before we look forward, let's take a look back. And for that, let's go to Patrick talking about smoke impacting the Sacramento region this past weekend. Patrick.
Thanks, Jeff. As you mentioned, we will be focusing on smoke in Northern California. And what I have showing right here is a satellite image the morning of Friday, August 6th, which is showing significant smoke buildup in Northern California from multiple large fire complexes in the northern part of the state, especially the Dixie Fire. You can also see a large amount of smoke being transported off to the east across Nevada, Utah, into Idaho, as well as all the way across the country, really. But we're going to be focusing more on this area in particular. And what I want to show, in addition to this smoke, is the observations of wind and the air quality at this hour. So it looks like the whole area is just being inundated with smoke from these fires, and really dense smoke that's obscuring our view of the surface here. And you can see some concentrations. These are micrograms per meter cubed. Concentrations up over 200 and even 500 micrograms here in the foothills of the Sierras. But what I really wanted to point out was the better air quality through the center part of the Sacramento Valley. So this is right in Sacramento County. It's showing green and concentrations that are in the single digits. And we're going to talk a little bit about what led to this situation, and specifically the occurrence of aloft smoke versus surface smoke. So when we're talking about the difference between aloft smoke and surface smoke, it's actually really helpful to look at the HRRR model output. And that's what I'm showing here. So the HRRR model incorporates fire detections in the model, and then it has a smoke model that produces smoke, and it estimates the surface level PM 2.5 concentrations due to fires, and that's exactly what we're looking at here. This, again, it's on the morning of the 6th of August, that's last Friday, and you can see that the HRRR was predicting really high PM concentrations here in the hills to the west of the Sacramento Valley and also in the Sierra foothills here. But you see this empty area here where the concentrations are much lower, and I want to show by comparison what the HRRR model was predicting, not at the surface, but 6,000 feet aloft. So the HRRR model is a three-dimensional model. That means it's not just predicting smoke production and smoke transport, it's also predicting how that smoke is distributed in the vertical in the atmosphere. So it predicts mixing and the transport at different levels. So up at 6,000 feet, it's showing a very different picture over Sacramento County, which is right here. It's showing very dense smoke. If we look at this color scale, it's got concentrations over 200 micrograms, but that's aloft. Now compare again to what it's showing at the same time at the surface. So what happened during this period, let me switch back over to the satellite view, is that the smoke was produced by these fires. It was transported by light north or northwesterly winds into the Sacramento region, but it stayed aloft through the morning hours. Now I want to go back to the HRRR image here and just move forward just a couple of hours. So this is at 1700 UTC, which is about 10 a.m. local time. And as I step forward, you can see that the center part of the valley really starts to fill in at the surface with smoke, where concentrations are really starting to shoot up at the lower elevations here. So now that's what the model predicted. Let's see what was actually observed. Again, this is earlier in the day. You see good or green air quality. And as I step forward, now we've got the same satellite image here, but I'm going to step forward several hours. You can start to see concentrations really start to jump up here. This is in Yolo and Solano counties. As I step further forward, now you're starting to see unhealthy AQI levels right in the center of the valley. So what happened here was that earlier in the day, since the smoke was aloft over the region, there was a separate air layer underneath where the air was cleaner. And then as the surface warmed up during the day because of heating, solar heating, then it started to mix in the vertical. And what it did was it mixed the smoke that was aloft down to the surface. And so you didn't just have high concentrations at higher elevations up here, you had high concentrations all the way in the center of the valley. And that day, I believe, was unhealthy for air quality for the 24-hour average in Sacramento County. It actually reached the hazardous AQI category for a few hours up in the foothills, but it was a pretty widespread event. It just took considerable time for that smoke to mix down to the surface. And it's really helpful for us to be able to identify these situations and be able to have an accurate forecast so that we can communicate that to the agency and the public, because a lot of times people see smoke in the air, they say, hey, it's really hazy, I'm seeing smoke, or the sun looks orange. Why aren't the AQI levels higher? And a lot of times it's because of this aloft smoke. But we were able, in this case, to communicate to the client that by the mid-afternoon, AQI levels would start to spike in the center part of the valley because of that daytime mixing of aloft smoke. So that covered August 6th. That was Friday. But now I want to move later in the day and into the 7th and show you what happened then. So I'm going to fast forward here 8 hours. And what you can see is a very different picture, really an intrusion of clean air through the delta here in the San Francisco Bay Area into Yolo and Solano counties and Sacramento County. And that was due to some onshore winds. So these good air quality levels were in spite of the fact that it looked very smoky. Again, it was because of a different situation at the surface compared to aloft. And if I fast forward even further, here on, this is now August 7th on Saturday, still good air quality levels at 8 a.m. And then what happened on the afternoon of the 7th, even though there had been this intrusion of cooler, cleaner air, again, once the surface started heating up and you started to get some mixing in the afternoon, you can see that despite an onshore breeze, as indicated by the wind barbs here, that the AQI levels did start to increase in Sacramento County. Now, it wasn't as dramatic as on the 6th because we're getting a little bit of help from the onshore breeze here, but it's still another one of these days where there's sort of this aloft reservoir of smoke that you can see on satellite, but it may not be at the surface, and then as it starts to warm up midday, you get that overturning or that mixing, brings the smoke to the surface, and the AQI levels start to increase. And with that, I'm going to turn it over to my colleague Steve, who will talk about the AQI levels observed a little bit farther south on these days.
Yeah, thank you, Patrick. Being on forecasting last weekend in the Sacramento region, it was a very tricky forecast, trying to figure out how much smoke was going to make it down to the surface versus how much was just going to be aloft, and how that would affect air quality levels throughout the Sacramento Valley out to the coast, but then also up into the foothills. This image that I'm going to show here shows just how shallow the good air quality was in the Sacramento Valley. So this is something we look at as forecasters. It's called a skew-T diagram. And it's basically just showing temperature, which is this line off to the right here, and dew point, which is this line off to the left. And we're looking at a vertical slice of the atmosphere. So we're not looking horizontal, we're looking up as a vertical slice into the atmosphere. And what this is showing, these cooler temperatures down near the surface, is where that cleaner air was located. And so really it was just from the surface up to maybe just under 500 meters or 1,500 feet, that cleaner air was underneath that smoke that was aloft, keeping air quality levels much better in the Bay Area and in Sacramento versus up in the foothills. Now, as the day progressed, as Patrick mentioned, that changed as the sun was at higher angles. That was able to mix a little bit more and bring some of that smoke down to the surface. And so it's interesting as we think about more smoke aloft can actually mean better air quality down at the surface, especially in low elevations. Whereas sometimes if we have less smoke, less total smoke in the atmosphere aloft, that can actually make smoke worse at the surface because it's able to mix down better with thermal mixing, with more solar energy occurring. And that is what we saw on that day. So going back to the same time frame, Saturday afternoon, August 7th, as we're looking up into the Sacramento area, we're seeing PM 2.5 concentrations in the 20s, low 30s, some mid 30s. And even as we get back in toward the Bay, more toward the single digits. However, as we look further south into the valley, the San Joaquin Valley from Modesto down to Fresno, we're seeing PM 2.5 concentrations into the 80s, which is in the unhealthy category. And it doesn't make sense at first because you're looking at this map of smoke and you can see much more dense smoke here. And then as we go down the valley, the smoke gets less thick. And that's just because what we've been talking about, the smoke aloft actually blocked the sunlight, which led to less atmospheric mixing, which made the process slower for the smoke to transport to the surface. Whereas further south, there was more solar radiation. The smoke was a little thinner aloft, and that was able to transfer it down to the surface, making AQI levels, PM 2.5 concentrations much higher. And if we go back to look at some of the webcam images from that afternoon, we can really see this difference from low altitude smoke to what was happening at the higher elevations. This one is from the Sutter Butte camera, which is on the northern side of Sacramento at about 3,000 feet. Actually, this one is 2,096 feet. And you can see how dense and how thick that smoke is, both aloft and getting down toward the surface. But then as we get back towards the coastline, we can see that smoke was really more just aloft, and the visibility is much better down at lower elevations. So that's really the trick when it comes to smoke forecasting. Is it going to be too thick aloft for it to get to the surface? Is it going to be just thin enough aloft for more smoke to mix down to the surface? And so those are some complexities that we have to think about. And also just to mention, as we're looking at the models going back to last weekend, both the HER model and there's also a Canadian smoke model, they both did very well forecasting this event. But if we only look back to the end of July, there was another event that happened in Sacramento and in the foothills that wasn't as well forecasted by the air quality forecast models. And what we've been talking about as a group to why that might have been was that there was so much smoke that the fire detections weren't being picked up by satellites. So that the model initializations, or what the model's starting with as an idea of how much fire is out there and how much smoke those fires are producing, wasn't being initialized with the right amount of fire and smoke because the satellite imagery was blocked by all the smoke in the atmosphere. Now this particular event, the models did much better because I think they had a more clear view of the fires before the smoke was transported down into the valley.
Steve, I wanted to jump in really quick. If you could go back to the skew-T diagram. I wanted to point out that, so basically what this is depicting is a very, very strong inversion very near the surface. And a lot of times when you hear about inversions, they talk about the meteorologists talk about bad air quality. We associate inversions with trapping pollutants near the surface, but that's not always the case. Sometimes an inversion can actually work towards your benefit air quality wise. And in this case, that's exactly what happened. The inversion prevented the mixing down of aloft smoke. And once that inversion broke because of surface heating, then the smoke mixed down. So it really depends on the situation. Sometimes we can have smoke trapped below an inversion, but sometimes the smoke can remain above an inversion. The inversion serves to really separate two levels of the atmosphere.
Yeah, and I think that's another key point, is knowing what the air is like underneath that inversion, if it's going to be have the smoke in it already, or if it's going to produce that protective barrier. And I think as we're looking at the upcoming forecast for the next couple of days, that's one of the key questions that we're trying to answer.
So with that, let's hand it back to our colleague Jeff, who's going to talk about the smoke and air quality outlook in Northern California for the next few days.
All right, Patrick and Steve, thanks for that. And it's a little bit of history repeating itself, because as we head into the upcoming weekend here in Northern California, smoke back into the forecast, and a lot of forecasting challenges that we are trying to figure out as far as where the smoke is heading, how much of that smoke mixes down from aloft down to the surface, and how that will impact not only air quality levels, but ozone levels as well. And we're going to get to that momentarily. First, I want to start with this, though. This is satellite imagery for Wednesday, August 11th, around 3:15 in the afternoon. As you can see, there is a lot of smoke in Northern California, in southwestern Oregon, and this plume of smoke extends several hundred miles offshore, hovering over the Pacific Ocean. So that's part of the forecasting challenge heading into the weekend, all of this smoke that is sitting over the Pacific Ocean. Before we get to that challenge, though, I want to talk about the nuts and bolts as far as the forecasting setup, because as we head into the next 48 hours here, heading into Thursday the 12th, Friday the 13th, high pressure, surface high pressure begins to develop off the California coast. Now, what does this mean for Northern California? All of that smoke that's sitting off the coast may start to move its way back onshore and into places like San Francisco, Sacramento, and also the Feather River Valley. This would be Yuba and Sutter counties. So here is Thursday afternoon, and these are the winds in the lower levels of the atmosphere, around 2,500 feet. And you can see some of these winds coming out of the northwest and then westerly through the delta around the San Francisco Peninsula, and then extending toward the Sierra foothills and the Sacramento Valley. By Friday, that area of high pressure a little more pronounced. And you can see those winds are a little more pronounced out of the west to northwest. And again, opening up that door for smoke transport from the Pacific Ocean back into San Francisco, Oakland, Sacramento, and Yuba and Sutter counties. One tool that we utilize here at Sonoma Technology when we're making up our air quality forecast for clients is the high split model. And this will take a look at trajectory paths over a period of time at different levels of the atmosphere. So what I did here is run several trajectories that are ending at about 11 o'clock in the evening on Friday, going back 48 hours. So this goes all the way back to what amounts to late Wednesday night on August 11th. And what we're seeing here is that transport path is showing northwesterly winds coming right down the California coast. And much like we saw there on Windy just a few minutes ago, the transport path through the Delta and into Sacramento, into Yuba and Sutter counties, as well as the San Francisco Bay Area. Should also point out here that we do have smoke plume analysis from today, August 11th, and fire detections from the numerous wildfires burning across Southern Oregon and Northern California. So that's what we know. We know there's a lot of smoke over Northern California, Southern Oregon, and also offshore. And we know that the winds aloft, at least in the lower levels, will begin to turn northwesterly, opening the door for smoke transport into the Bay Area and the Sacramento Valley. We also know that the AQI values are probably going to trend upwards, but just how high will those AQI values get? Well, that's one of the big questions as we're heading into the next 48 to 72 hours here in Northern California. We take it back to the HER smoke model, and this is the vertically integrated smoke product. As Patrick was talking about earlier with the HER smoke model, it's a three-dimensional model. It takes a look at smoke not only at the surface, but for several thousand feet up in the atmosphere. So this is total column smoke from the surface into the upper levels of the atmosphere. And this is output for the vertically integrated smoke product for Thursday evening around 5 o'clock. And you can see vertically integrated smoke, there is a lot of total column smoke across Northern California. However, at the surface, not nearly as much smoke. So that's one of the problems that the HER smoke model has, is resolving how much smoke is at the surface when that smoke isn't over land, when it's over the Pacific Ocean. We do have another tool that we can look at, and this is the Canadian Firework model. This is one that Steve was just talking about earlier. And this is taking a look at surface PM 2.5 or smoke. And this is for the same time frame for Thursday evening, the 12th, around 5 o'clock p.m. This shows a little more surface smoke around Yuba and Sutter counties and the Sacramento Valley. But watch what happens as we head into Friday. This will be Friday morning, and watch what happens Friday afternoon. So this is Friday afternoon and Friday into the early evening hours, and a lot more smoke is forecast to make it from aloft down to the surface, increasing PM 2.5 levels. So again, smoke transport possible heading into the next several days here in Northern California. As far as how much smoke is going to make it down to the surface, that is a big question. And how that smoke may also impact what is going to transpire with ozone levels for the next several days. If the smoke layer is too thick, ozone levels will probably not respond. Typically, a thin layer of smoke can lead to enhanced ozone formation. But if that smoke layer is too thick, then it's the other way around. Smoke level, or rather ozone levels, go down. Want to go into the forecast here. This is the Bay Area Air Quality District forecast as we're heading into Thursday, Friday, and Saturday. Moderate AQI levels in the forecast as that smoke mixes down and some of it reaches the surface. For Sacramento, it's basically the same forecast for smoke, although ozone may be enhanced as well. And that is why, as we're heading into Friday and Saturday, unhealthy for sensitive groups AQI levels are in the forecast. Finally, I want to go over to the Feather River Valley. This would be Yuba and Sutter counties. Yuba City forecast, moderate AQI levels for ozone today, but for tomorrow and Friday, moderate PM 2.5 levels due to that smoke moving in from the Pacific and the California coastline.
Worth noting too, I think on Friday that ozone levels are forecast to drop in Sutter and Yuba counties because of the density of that smoke, even as PM levels climb up into the high moderate category.
Absolutely. And again, that's one of the several things that we are tracking with this forecast over the next 48 to 72 hours. By no means a forecasting slam dunk, a lot of challenges with it. But the take-home message for those of you watching in the Bay Area, Sacramento, Yuba, and Sutter counties, expect AQI levels to rise over the next couple of days, with some smoke moving in from the Pacific Ocean toward the Bay Area and then up through the Delta into the Sacramento Valley. Well, that wraps up this week's air quality discussion. To see some of the amazing work that we do here at Sonoma Technology, you can head on over to www.sonomatech.com. Of course, the High Pressure Podcast. We are on Twitter. Follow us. We're at High Pressure Pod. I'm Jeff Beamish.
I'm Patrick Zahn.
And I'm Steve Irwin.
Thanks for listening to and watching the weekly air quality discussion on the High Pressure Podcast.